Now, we turn to the continuous probability distribution. We're given this function f, and f is defined in this way. When x is between 0 and 1, then fx equal to 4 times x times 1 minus x squared. And when x take on the other values, fx will be equal to 0. And we want to determine whether this function f is a legitimate probability density function or not. So remember, there are two criterions for the function to be a PDF, that is a probability density function. The first one is fx must be always greater than or equal to 0. And the second part is if we integrate over the real line, then the result of integration is equal to 1. Okay? So in this case, we can see that the fx is always greater than or equal to 1, no matter when x is between 0 and 1, or take on some other values. It is always greater than or equal to 1. It is always greater than or equal to 0. But for the second criterion, it is not so obvious. We have to do some calculation. So we will have to integrate this function f on the real line. Because it only has non-trivial function value on the interval from 0 to 1, so we only need to care about the x from 0 to 1. So that means we will have the integrate over the real line of fx dx equal to the integration from 0 to 1. And then we plug in the actual function on this interval. That is this. And then it is a matter of integration. And we can firstly multiply the 4x into the parentheses. That is, we have 4x minus 4 times x cubed dx. And then if we integrate it, we will have 2 times x squared minus x to the 4th. And the limit is 0 and 1. And then we plug in the numbers. We will have, firstly we plug in when x equal to 1. And then we will have 2 times 1 squared minus 1 to the 4th. And then minus we plug in the value of x equal to 0. We have 2 times 0 squared minus 0 to the 4th. And if we do the algebra, we'll have 1 minus 0. It is equal to 1. So we can see that the second criteria is also satisfied. So we can conclude that this function f is a legitimate probability density function. Now let us go to the second portion of this problem. And suppose x is a continuous variable, random variable with the given PDF fx. And we want to set up and evaluate the mean of x. Remember, for a continuous random variable x, its mean is denoted by ex, and it is given by an integral over the whole real line with the integrand of x times fx, then dx. Okay? So again, because when x is not between 0 and 1, it is always 0, so we only need to care about the part of x when it is between 0 and 1. So we plug in this formula. We have integration from 0 to 1 of x times the fx, that is 4x times 1 minus x squared, then dx. A bit of algebra, we can rewrite this as the integral from 0 to 1 of 4 times x squared minus 4 times x to the 4th of dx. Okay? So now we need to integrate this function. So if we integrate the first part, this 4 times x squared, we will have 4 over 3 of x cubed. If we integrate the second part, we will have 4 over 5 of x to the fourth. And also remember the limit is from 0 to 1. And then, if we plug in the numbers, we will have 4 over 3 times 1 cubed minus 4 over 5 times 1 to the fifth, and then minus 4 over 3 times 0 cubed minus 4 over 5 times x fifths. And then if we do the calculation, it is equal to 4 over 3 minus 4 over 5. And simplified, we will have it is equal to 8 over 15. And now we want to set up, but you don't have to evaluate the variance of x. And then also set up and don't have to evaluate the standard deviation. Okay? So remember, the standard deviation, I will abbreviate it as SD, is equal to the positive square root of the variance. So our main job in this part will be finding the variance of this random variable x. So remember, the formula for the variance of a continuous random variable is given by the integral over the whole real line of x minus mean square times the PDF fx. Okay? So from the second part, we already find the mean is equal to 8 over 15 from the second part. So we can plug in the numbers. Again, because we only have non-trivial function f on the interval from 0 to 1, so we can replace this whole real line r by just 0 and 1, then x minus mean, which is 8 over 15 squared, times the function f, which is 4x times 1 minus x squared dx. Okay? And this will be the setup of the variance. And then we will find the standard deviation, that is the positive square root of the variance. So we will have the square root of the integral from 0 to 1, and then x minus 8 over 15 squared times 4x times 1 minus x squared dx. And this will be the result for the standard deviation. Next, we want to find the probability when x is exactly equal to 1/3. Okay? So because we're dealing with the continuous random variable, okay, I will use RV to represent random variable. And then the probability of x equal to a single value, I will use small x to represent a single value, then this probability is always equal to 0. So in this case, we have the probability of x equal to 1/3 is equal to 0. Okay, so probably you will have to use this result, this part of the result in your exam. So please always remember that if x is a continuous random variable, then the probability of this x taking on any particular value will be equal to 0. So this is it. Alright, next we want to find the probability when x lies in between 0.3 and 0.8 with the endpoint included. Okay, basically in the first part we want to find the probability of 0.3 less than or equal to capital X less than or equal to 0.8 because we want the endpoints to be included, so we will have used the less than and equal sign. And if we want to find the probability of a continuous variable within a region, we're doing integration. So that means we're going to integrate from 0.3 to 0.8 of the PDF. That is 4x times 1 minus x squared. And in this part, we will have to evaluate this integral. And again, we can break up the parentheses, have 4 times x minus 4 times x cubed dx. And if we integrate the first part, we will have 2 times x squared minus, if we integrate the second part, we will have x to the fourth. And our bound in this part will be from 0.3 to 0.8. And then if we plug in the numbers and use your calculator, we will find the probability is equal to 0.6985. Alright, this is the first part of this problem where we find the probability when x is between 0.3 and 0.8 with the endpoints included. And then we want to find the probability of x is strictly between 0.3 and 0.8. And in this part, we will have to, basically it is a problem considering about what is the probability of x equal to 0.3 and the probability of x equal to 0.8. Like what I said earlier in this in the previous problem, for a continuous random variable, the probability of taking on a particular value is equal to 0. So this probability is equal to 0, and this probability equal to 0. That means the probability of x is strictly between 0.3 and 0.8. There's no equal sign here. Will be equal to the probability of 0.3 less than or equal to x less than or equal to 0.8. So there's no difference between those two quantities. Alright, this is a problem on the continuous random variable.